Okay, so we're going to talk about a few different things you can do in engine performance with the oscilloscope. So typically this is kind of one of the major tools that we use quite a bit in engine performance. So I've been asked by a few students to kind of demonstrate some of the more common procedures that we would use the scope for. So we're going to do a couple of those today. I wanted to show you the Pico cart and kind of get you familiarized with it if you have not used it before. This is the newer of the two Picos. Essentially both of them operate about the same way. They're not quite organized the same way, but a lot of the tools are very similar. They may look slightly different, but most of them have the same purpose, so most of them are kind of organized and work the same way regardless of which one you're using. So right here in the top, I'm bringing it a little closer here. Right here in the top of the cabinet, you're going to see a few components. This is the scope interface, so we will need this. This is a 4-channel PicoScope, so we got 4 channels. We can measure 4 different signals all at the same time. The USB port's right on the back here. Okay, and then it has a USB cord for your PC. Works like any other USB cord. It's a USB 3, so plug it into a blue USB port if you've got it. If you don't have a blue USB port, the regular 2.0 will work. So that's the interface module. Set that over here. These are the cables you're going to use anytime you're measuring voltage. So all of these are a BNC type connector on the front of the scope. This connection is pretty easy. It's basically, you go on, it is keyed, so you got to find the area and then push forward, and it's just a quarter turn. That's all you're going to turn those, so you should be very, very gentle with these. These do break from time to time, and then to loosen you just quarter turn back and just a slight pull. There should be a bit of a drag on those connectors, so sometimes they are a little bit tough to pull off, but as long as you do the quarter turn left, they should pull off just fine. So these, anytime you're measuring voltage on any circuits, if you're measuring an actuator circuit, we'll get into attenuators later, but anytime just in general you're measuring any kind of actuator, whether it be an ignition coil or an injector or a solenoid or anything like that, it's a good idea to hook up one of these attenuators first. So these go in line with this cable, and then this would plug into your scope. What this does is it drops the voltage that this line is sending to the scope, and in this case this is dropping the voltage by a 10-to-1 ratio. So we use this just in case that actuator has some back feedback that exceeds the voltage limit of the scope. We don't want to damage the scope. So the attenuators are right here. There's 2 of them. So anytime you're using these, if you're unsure, use an attenuator. If you use the attenuator and it comes back and the voltage is low enough for the threshold on the scope, you can go ahead and remove the attenuator and go from there. So we have 4 of those cables. They're all color-coded, red, blue, and green, and yellow. Anytime you're measuring voltage on any kind of circuit or sensor circuit or anything like that, or looking for a signal of some sort, data signals, you're going to all measure those with those voltage cables. So this scope has a few capabilities outside of engine performance. One of them is vibration diagnostics. We call it NVH diagnostics. So all of those tools are right here. We probably won't get into those until a little bit later on or in your comprehensive diagnostics class. So those tools are over here. You can pretty much ignore those for most of engine performance. In the rest of this top drawer, we have some various clamps and things like that. So we got ground clamps in here. We have DVOM style probes. These just have a cap on them. These are very, very sharp, so be careful with these. So we got DVOM probes. We have some banana plugs. Need to plug into something that's got a banana plug on it. And mini clamps, so those are all there. They also come available in red. And then there are also field repairable back probes in here, so I never recommend disconnecting anything, especially engine performance related, if we don't have to. So these back probes are handy because we can actually back probe connectors. We don't have to disconnect anything to make a voltage reading. So we'll probably be reusing these today as part of our demo. This does come with some hooks. So you notice the nylon strap on the back of the Pico. Back here, these nylon hooks are designed to use these, and you can hang this on, say, a hood rod, like the latch mechanism. So go over here with this, hang it like that. USB cord comes off. All your signal cords are coming from the bottom. It's a good, easy way to kind of control and manage cords. If you're doing more than 2 signals or so, it can get kind of cordy up in here. So it's something to utilize when you can. So that's that. Going back to our cart, over here. One of the more handy tools that we're going to demo today, this is a coilover plug probe. So this probe is an inductive probe. It's got an inductive coil in the bottom here, and some processing circuitry. You use this with an extension cable that I'll show you in a minute. But you can use this to probe the top of ignition coils and things like that. So I'll take you out over here. You could lay this right on top of an ignition coil, and we should be able to actually get a ignition waveform just out of this probe. So it's a non-contact probe. It's nice to be able to use that because on some vehicles, coilover plug, you may not have room to actually go through and measure secondary voltage. So that's a good way to actually get secondary voltage. It's programmed into the PicoScope software, so everything's compensated, so it actually gives you a valid voltage reading. So nice tool, something that's going to save you a little bit of time from here and there. So in this second drawer, we have most of our amp clamps. So we have 2 low current amp clamps. These are 20 and 60 amp clamps. And then we have a high current amp clamp. This is a 200 and 2000 amp clamp. You should only use the 2000 amp clamp if you're going to be measuring amperage that's kind of above the range of these lower amp clamps, or if the wires won't fit through these lower amp clamps. So starter wires and things like that, it's a good thing to use. If we're doing parasitic draw or something like that, I definitely recommend the low amp clamps, because the high amp clamp's just not going to provide a ton of resolution down low. So we've got 3 amp clamps. Please make sure these are off, so when you leave these on, they drain the battery. There is an internal battery on them, but when you leave them on, they do drain the battery. When you turn these on, if that low bat light is on, just go ahead and replace it. You will not get accurate readings that way if you leave it that way. So a couple other handy tools, especially for ignition waveforms. These spark plug extensions allow you to remove an ignition coil. So on this vehicle, since it's coilover plug, if we look at this vehicle, we would have to remove this ignition coil because we can't get to the secondary. So we've got access to the primary up here in the wiring, but we'd have to remove this cable, or coil, excuse me, and then this end would go down in the spark plug hole, and then this end would plug into the bottom of the coil. So this is a handy way to break out that coil. You can kind of pull it up, lay it on the top of the engine, and use this extension. And then the tool you're going to use to actually measure secondary voltage is a regular secondary probe, which is down here in the 3rd drawer. These are a regular secondary probe. So this is a ground clamp. You clamp this to a good engine ground, typically. This is your end that goes to the scope. The BNC connector looks a little different, but it is the same, works the same way. And then this end we clamp around our spark plug wire. So if we have a vehicle that, say a waste spark vehicle or a distributor style ignition vehicle, we would just find the closest spark plug that we want to measure and clamp that around that. Be sure that that's closing all the way. If it's not closing all the way, you may not get the cleanest signal. But if we have a coilover plug vehicle or something like that, or a waste spark vehicle that has the coils sitting right over the plugs and we don't have accessible spark plug wires, these are a good way to get that. So you can pull that coil out, hook that up. It's real simple, real easy to do, and you can get your waveform that way. So this is the ignition secondary probe. You're going to use this for the most part on ignition secondaries. You can also do a primary waveform, which we'll do today. But yeah, really, ignition primary and ignition secondary are the same. So if you can get either one, it's going to tell you most of what you need to know. Other things in here, this is the extension cable. This is to be used with certain tools that go BNC to BNC. So things like Firstlook, you can use this cable with. The Firstlook also has its own extension cable in here that's a little bit longer. But then we would use this cable for this tool, since this tool has the BNC on the back. It doesn't really matter which end you plug into which in, but this does need to be grounded to the vehicle for a cleaner signal. So I think this end of the cable is a little bit shorter, so I would usually err towards putting whatever end is closer to that ground cable on the probe, and then have the other end running to the scope to get your signal. So that's the cable for that. Other miscellaneous items, there's a probe kit in here that has all different size connectors, Metropack and round pin connectors, so that if you're trying to break out a connector, maybe we've got let's say a mass airflow or something like that, we've got 5 circuits or something like that we need to break out. These are shorted together inside this banana plug. These just pull apart. These are shorted together inside the banana plug, so we've got a male and a female end. So we could disconnect the OEM connector, plug this into the female end, plug this into the male end, and then we've got a port for voltage measurement right there. So these get disorganized all the time. So a good example here, I've got round and flat blade all in one. So apparently my last flat blade is somewhere else in this assortment, but there should be, I believe there's 6, one of each color, of each of these in each different size. So you've got a wide assortment there. This just folds up. Other miscellaneous items, if you're using an amp clamp and you break into a circuit, you want to get into a circuit that's fused and only that device that you're testing is fused, meaning there's no other things running on that circuit or that fuse other than what you're testing. These are handy to have. These are fuse buddies. This is an ATC style fuse. This is an ATM style fuse. I'll show you this in a minute. So as I was saying, I had to move the camera a little bit so you can get a good shot at this, but all these ATM fuses, so I just pulled this one out of here, all these ATM blade fuses go inside these fuse buddies. So say I was looking at this circuit, Ford doesn't really put a description on their fuse panel, so I'm not sure what that circuit is, but if I was interested in whatever that circuit was powering, I would remove that fuse, slide it into my fuse buddy here, and now this is your new circuit. So now this fuse buddy is part of that circuit. We can plug that back in to the fuse holder, and now we have a current loop that's in the circuit, in series with the circuit, that we can then take our amp clamp. In this case, since it's a small fuse, we can take our amp clamp and clamp around that. So we can break out many of our engine circuits and things like that. Injector circuits are great to do this on, because typically injectors or coils are powered by one fuse. So we can break that out and actually get a waveform on many of our or all of our injectors or coils. So those are fuse buddies, really handy tool. There's 2 sizes, 2 blade fuses. We do not have anything compatible with these fuses, so in this case we would have to make something to break those out. But in many cases, those larger fuses, you're not really going to want to use a fuse buddy and an amp clamp to look at a circuit that's powering multiple loads. Alright, so I wanted to give you guys a little bit of a shot of the tools that we're going to be demonstrating today. So all of these tools are primary tools that we're going to use quite a bit in engine performance. So starting over here on the right, or your left, we have our voltage measuring tool, so a voltage cable. These again, you just work just like a DVOM probe, so you can use these on anything you would use a DVOM for. Again, I highly recommend, especially until you know what you're doing, go ahead and use these attenuators. So use the attenuator first, check the voltage, see what the voltage measures at. If it's too high for the scope, continue to use the attenuator. If it's below the limit of the scope, which varies depending on which scope you're using, if it's below the limit of the scope, you can go ahead and take this out and just use a bare cable. A couple of the other tools that we have available here, this tool over here on the right is called the Firstlook sensor. This is a pulse sensor. You'll hear me talk about this tool a lot. It's pretty useful. We will demo this today and see what we can actually see on this vehicle. But you can essentially diagnose times it works really good. Other times it has some trouble picking up a good clean signal. So we're going to try this one. This is the newer version of it. So we're going to try this one and see what we get. You use this tool with this cable, this BNC cable. Remember, this is the grounded cable. So make sure you ground that to an engine ground. You can also use this cable with the Firstlook sensor. The Firstlook sensor does come with its own cable. It's a little bit longer. It makes it easier to use. If you're going to go directly probing a secondary circuit, this is your probe you're going to use. It has these funny looking clamps on it. These go around the spark plug wire, as I said. And then we have these breakout spark plug wires if we have a coilover plug vehicle. So if we have a coilover plug vehicle like this one we have here today, we're going to have to remove that coil, break out that secondary lead, and then we can clamp on that secondary lead probe there. I'm also going to show you the amp clamp. So the amp clamp's got a lot of different uses. We're going to actually use 2 different amp clamps today. We're going to use this low amp clamp for some other ancillary circuits, and then we're going to use the high amp clamp, and we're going to go after something called a relative compression test on this vehicle. So we're going to do a relative compression test. We're going to compare this compression of all 4 cylinders, and in that case we can very easily quickly test to see if we have an engine that has a single cylinder that's maybe down on compression or something of that nature. So that's it. We're going to go ahead and pull the coil off this vehicle, and we're going to go from there. Okay, so the first thing we're going to do, we went ahead and removed an ignition coil. The first thing we're going to do is we're going to try to get a secondary ignition waveform, and we're going to do this the direct way first, since we have some other coils that are already that are continuing to be installed. So we're going to do a direct measure of the secondary resistance. There's a few reasons we would do this. Number one, primary voltage and secondary voltage measurements, which is what we're doing here. Those measurements are really the only way that we can get a glimpse of what's going on in the cylinder in real time while the engine is running, without drilling other holes in the cylinder head and putting pressure transducers in and all that kind of thing. That's about the only way we can do this. So this is really our one and only opportunity to get a glance at what's going on in the cylinder. We can diagnose things like rich and lean conditions. We can diagnose compression issues, secondary resistance issues, all those types of things very easily using this method. So what I'm going to do is I'm going to put this cable down here in our spark plug hole. We're going to push it until it clicks. You might not be able to hear it click, and then we're going to put this end in this coil loop. And then this coil is just going to kind of chill out on top of the engine. So we're going to flip this connector around, if you can see that real well. We're going to flip this connector around and just plug it back in. We're not going to lock it, we're just going to leave it chill out there. And it's just going to sit there next to our spark plug hole. And now we have a secondary lead that we can clamp onto our secondary voltage lead for the Pico. So we're going to come over here and grab our secondary probe, this guy right here, and we're going to unwind it a little bit. We're going to go ahead and plug this into the first port on the PicoScope. So this is going to go into port A. So I've got my PicoScope hanging up here. We're going to go into port A with this. It's 1/4 turn, that's it. I've already got my USB cord hooked up. I don't know if you can see that up at the top, but the USB cord is plugged in. And then I've also got it plugged in over at the laptop too. So we're going to plug our secondary probe in. And then we're going to come down here to the engine side. Run this around the outside so you guys have a view. And we're going to go just over the drive belt here, and we're going to come down here on some engine mount bolts. This will be a good ground for us. And then we're going to clamp this lead right here in the secondary. So now we're ready to capture a secondary ignition probe. And we're going to go over here to my laptop and take a look at what we're doing on the laptop. So we'll bring this screen up. PicoScope 6 Automotive is our software. It is free software. You can install it on your own laptop, and I do recommend most students install it on their laptop. There's some demo features that allow you to play around with some stock waveforms and allow you to kind of get a feel for what different settings do and things like that when you're viewing those waveforms. So I do recommend that you go ahead and take a look at that and download that software because it is free. It also means that you can save waveforms while you're in the lab and take them home, and you can manipulate them after the fact in the lab. So it's a really nice learning tool. They've got a lot of educational content on their website that helps you when you're just starting out with the scope. So the first thing I like to do when I fire up the PicoScope software is I like to open my channel options. You do that by clicking the A, B, C, or D, depending on what channel you're using. So up here, your channel A, and we need to tell it what probe we're using. So all these ×1, ×10, ×20, ×100, all of those probes are for our voltage lead only. So we're going to go down and we're going to search for secondary ignition probe. So down here I have secondary ignition probe. I have two options, an inverted or positive. I'm just going to choose one and we're going to see what the waveform looks like. If that waveform's upside down, we're going to choose the other option. So we're going to set the voltage threshold up. So we're going from -5 to -20 or -5 to 20 kV. We're going to see how much that gets us. And then I'm also going to extend my time base. So remember, with a scope, your voltage reading is here. So now my scale goes from 0 to 20 kV. And on my time base, I'm doing across here. So I'm doing how much time am I capturing. Right now I'm at 5 milliseconds per division. So up here, 5 milliseconds per division. I think I'm going to go to 20 milliseconds per division, just give myself a little bit more time. Okay, so I'm going to start the vehicle up. So now we've got this vehicle running, and if you'll notice down here, our waveform is upside down. So that doesn't look like a normal ignition waveform. So the first thing I'm going to do is I'm going to change my probe, and I'm going to go to my other probe setting. So I'm going to go back here to my channel options and go secondary ignition probe inverted, and now it looks a little bit more like a normal ignition waveform. Now the other thing I'm noticing is that this waveform is jumping around a lot on the screen. The way I solve that is the scope does not know when this waveform is going to happen. So the scope refreshes at a certain rate and the ignition coil fires at a certain rate. They may not be the same rate. So what I need to tell the scope, if I want to see this waveform more clearly, is I need to tell the scope when to start recording data. So I'm going to do that by setting a trigger. So I'm going to come down here and I'm going to tell it I want a repeat trigger, which means it will continually recapture. And right now it's already recapturing data pretty well. I'm going to raise this value up. I'm going to put it over here so I can get multiple waveforms. And what I did is you can drag that around and that sets your trigger threshold. So down here at the bottom you see 4.9 kV. That 4.9 kV means that anytime the scope measures a value above 4900 volts, it's going to begin drawing a waveform for us. Now I am receiving an error up here in the corner. Occasionally I get a channel overrange error. That means my voltage threshold is set too low, or I'm not seeing the entire waveform. So I need to go up here and tell it I'm going to measure the next value up. So went to -5 to 50 kV. So now I get the whole ignition waveform every time. Looks like this ignition waveform is about what I would expect for this vehicle. It's a little higher than most vehicles because it's gasoline direct injection. So this ignition waveform looks like it's in good shape. We can zoom in on this or we can zoom out. So if we zoom out and set our time base longer, we will get more captures of more ignition events. So each one of these is an ignition cylinder firing event. When I go more narrow or a shorter time base, now my ignition waveform you can see has lengthened out. So this is the length of the spark. This doesn't mean the spark got longer in duration, it just means that the scope is displaying a shorter duration of time. So that waveform is more spread out, so I can more adequately see some noise and things like that going on in the cylinder that I maybe could not see before. Okay? Another good trick for this is if I extend my waveform out and get two of these ignition cylinder waveforms, I can measure an entire cycle of this engine. So if I pause this by hitting the space bar, I can go over here to the bottom right corner and I can drag out my rotation rulers.
My rotation rulers allow me to set 720 degrees worth of engine rotation based on when my spark events happen, because again, we should have 720 degrees, 2 full crankshaft revolutions for 1 cycle of a four cycle engine. So within those rotation rulers, now I have the entire engine represented. I know now that I can take these rotation rulers, and anywhere in between them, I can drag out even spacing and see all of the cylinder events for every other cylinder as well, and I can supplement that with other sensors. So we're going to do that next with an amp clamp.
Okay, so the next example that we're going to go through, this is one example why we would use something as simple as our ignition probe hookup to go ahead and try to understand what's going on with an engine. So we're going to do something called a relative compression test, and we're going to do this with the larger of the 2 amp clamps. So we're going to do it with the 2000 amp clamp. We're going to put it on the 2000 amp mode, and we're going to go ahead and find the battery cable. So over here on the left side is we have our 2 battery cables. We're going to go ahead and clamp this around either the negative or positive. In this case, we're going to go around the positive. We set this amp clamp to the 2000 amp mode, and then we're going to go over here and take our BNC connector, and we're going to connect to channel 2 of our scope. So channel 1 is still our ignition pickup. Channel 2 is now going to be our 2000 amp clamp. So when we go into the software, we're going to go down here, and when we go into the software, we're going to again click our channel option. So we're going to click channel B, and we're going to tell it what probe we're using. So we're going to use the 2000 amp current clamp, and we're going to tell it it's in 2000 amp mode. So right now it's in the 200 amp mode. We're going to click 2000 amp, and then we're going to set our range. So since we're around a battery cable, we're going to be cranking this engine over. We're going to do the negative 200 to 500 amp range, and that should give us a good solid waveform. Now for our trigger point we're going to trigger off of our ignition signal. So that is why we left our ignition probe set up over here. This ignition signal is going to give us a way to understand how quickly our engine rotates over to that 720 degree mark. One thing we need to do before we do this test is we need to go ahead and try to disable the engine from cranking. There's a couple ways we can do that. We can either do a clear flood mode by depressing the accelerator all the way to the floor, and we can try that and see if it works. This vehicle may not have a clear flood mode, but if it doesn't, we're going to have to do some investigative work and figure out how to disable this engine from starting. So essentially we want a good long crank, something that will allow the starter to work a little bit harder than it normally would. Okay, so we went ahead and got our scope all hooked up. It looks like we are getting a signal. Looks like it's a little smaller than we expected, so we're going to go ahead and pull this range up and pull it back a little bit to about 200 amps. So again, we're using the ignition trigger just to tell the scope when to start capturing, and we're going to overlay the amperage waveform on top of that.
There you go. That's better. Alright, now I get to post it. So what we just did is we went ahead and cranked the engine over. And by cranking the engine over, we used the ignition probe to set our 2 capture points. So what we did is we were having some trouble with triggering on the ignition coil. Instead, what we did was we triggered on the amperage signal. So we told the PicoScope to start drawing the waveform at about 103 amps, and this is what we got. So this is a relative compression test, and if you look right here, we've got our blue ignition signal and then another blue ignition signal right here. This is 720 degrees of engine rotation. Since this is a 4-cylinder, we see 3 distinct amperage humps in the crank starter motor cranking circuit. The reason we look for this is if we had a cylinder that was low on compression, perhaps an engine that came in that had a misfire on a single cylinder, we would be able to not only identify that there's a single cylinder with a compression problem, but we'd also be able to identify which cylinder it was by using the firing order. So if we look at this, this is compression for cylinder 1, this is compression for cylinder 3, this is compression for cylinder 4, and then back to cylinder 2 before we see compression for cylinder 1 again. So these rulers that I was discussing, you can drag these rulers out. These rulers are 720 degrees of rotation. Each of these rulers should line up with the spark event that happens in that cylinder, even though we're not scoping it. So now we're going to go through and we're actually going to create a problem. So we're going to create a compression problem on cylinder 1. So we're going to expect that we see some kind of compression issue through this relative compression test on cylinder 1 when we crank the engine over. So now what we've done is we've taken the spark plug out of cylinder 1, so we're going to do this test again and demonstrate what it would look like if we had a compression issue on a cylinder. So now, in comparison to the other waveform we got, if we drag our rulers over 720 degrees there, if you notice the amperage is much lower on cylinder 1, so there's no hump here, so we get 3 humps in a row that represent 3, 4, and 2, but there is no hump, and it's repeated in this pattern multiple times when cylinder 1 is supposed to be on compression. So you can see that represents cylinder 1 on a compression issue. So now that we've taken you through ignition waveforms and getting an ignition waveform and getting a relative compression test done, I want to show you kind of one more thing with some of the voltage measurements, just basic voltage measurements. So again, we're going to be using this. It's just our voltage probe cord. I'm going to leave the ignition cord hooked up just in case we want to look at that, but for now, we're just going to be looking at this. So again, we're going to come over here to the PicoScope. Hook to channel 2, and then like I said before, these are banana plugs, so these will work with most of your back probes. They will also work with most of your terminal adapters and things like that. I think we're going to go ahead and we're going to scope the mass airflow sensor on this vehicle, so we're going to pull that up and see what kind of waveform we can get out of that. This is one thing you can do with the PicoScope. Since it works just like a voltmeter, you can actually be pretty proby with this, and you can do a lot of different things with this depending on what you're trying to measure. So since it's just measuring voltage and the PicoScope is a high impedance device just like a DVOM would be, there's not a whole lot you're going to damage by just probing things to try to find out whether or not they're working properly. So the first connection I'm going to make is the black wire on my voltage lead. I'm going to go all the way to the battery. You can use engine grounds too, but I prefer to use the battery. The best ground is the battery, so I prefer to go just straight to the source. I'm also going to use these back probe terminals. So these are extremely sharp, and they're designed to slide alongside the wire rather than pierce the wire. So you should not be piercing the wire with these. And then I'm going to try to get you in as close as possible to this mass airflow sensor. So we're in just a little bit closer. It's tough to go around the camera, but I'm going to pull some of this wiring loom back, and I'm just going to pick one of these wires and see, and I'm just kind of going to guess and see what kind of signal we get out of this. So I'm going to go ahead and start up the vehicle, and then we're going to go ahead and take a look at what we can get on the PicoScope. Okay? Now that the vehicle's running, I'm going to go back to my PicoScope screen, and we have to change our probe again because we're using a different probe. We're not using the amp clamp anymore. So we're going to go back up to channel 1, or channel 2, excuse me, and we're going to select probe 1. We also have to tell it what about voltage we think we're going to measure. So I think it's going to be somewhere around 5 volts or so. And then we're going to play and see what kind of signal we get. Now this looks kind of a little bit messy, so it could be a signal. I'm going to change my time division and see if there's anything actually there. So to me that looks like just about a whole lot of noise. There's not a lot of signal there. That might be a ground wire or something like that. So we're going to probe another wire next door. Ah, and there's a nice looking signal there. So all I did was move one over. So if you see this probe down here, all I did was remove my back probe. I think we were probed down this yellow wire. I just moved it over one to that white wire, and that appears to be the signal. So if we look at this, this is a signal. It does look like it's 5 volts. It looks like it goes from 0 to 5 volts. And it's pretty dense right now, but if I open or reduce my time base, as I reduce my time base, it starts to become clear what's actually going on here. So this sensor is outputting a digital square wave, and I would bet that as I rev this engine, we're going to see that frequency of that square wave change. We may also see the pulse width change. So the bars you're seeing across the screen may widen, but you notice it's pretty steady right now. So we're going to try to change the engine RPM and see what we get. So you notice as I rev that engine, we go back a few frames here. Oh, we may have lost some of that data. But you notice the effect on that frequency as that engine revs. So as the mass airflow saw more air going past it, the frequency and sometimes that pulse width changes. So that's something to look for when we're looking for a response out of a mass airflow signal. So we'll let this play. You can do different things with the car during this. We could do some uncalculated air and see what effect that has on the mass airflow. We could also do different small failures and see how that affects them, vacuum leaks and all that kind of thing. But this is a really interesting way to kind of interpret the mass airflow, because normally we just think of it as a data value in a scan tool. This is the actual signal going to the PCM. So the last test we're going to do is we're going to use the Firstlook sensor. And this is a sensor that not many people are familiar with. This is a very handy sensor. This is a pressure change transducer, which means that it only measures a voltage output or records a voltage output when there is a change in pressure. So if pressure is staying the same, it does not output any voltage. When pressure changes, it does, and depending on the degree by which it changes, it will output a higher or lower voltage. So you're riding along with me now. I've hooked the Firstlook up to the scope, third channel on the scope, and then we're going to go back here and I'm just going to show you just how easy it is to hook this up. So I'm going to unspool my cable here. Pardon my reach. But we're going to take our Firstlook sensor back here to our exhaust hose. And while the vehicle is running, we're just going to lay this guy, oh, it won't go in the tailpipe. So we're going to lay this guy in this exhaust cone. Try to get you a good shot at doing this. We're just going to tuck that guy right down in there. And we're going to lay our exhaust hose back up on the vehicle. Now we don't want to run the vehicle too long like this because it will eventually melt that Firstlook sensor. But we're going to go over to our scope and set up our reading here now on our scope. So I'm going to set you back up here on the tripod. So you got a nice view of what we're doing. And we're going to turn channel B back on. We're going to tell it is ×1. And we're going to look at a 500 millivolt waveform. Oh, sorry, I forgot. We're on channel... It's important to remember which channel you're on. We're on channel C for our first look. So We're going to turn this guy on. We're going to look at 500 millivolts. And now we got a good waveform displaying on that PicoScope. So now that the engine's shut off and it's a little easier to talk, I wanted to tell you a little bit about what we're looking at. So this was our exhaust pulses on this Focus. And again, I still have my my ignition coil hooked up. And that coil is a pulse there. And actually we need to drag our bars back out. We got a pulse there and a pulse there. So that's 720 degrees of rotation. Much like the relative compression test, we have 3 humps here, right? So 1, 2, 3, 4. We expect these humps to happen a little ways after that ignition pulse. So ignition happens, we go on our power stroke, and then we come back up on our exhaust stroke. So this is all delayed. So since we're back in the back of the car in the exhaust, these pressure waves are reaching the back of the exhaust at the speed of sound. That means that there is a little bit of a delay, but not too much. It's more about the rest of the stroke of the engine than anything. So this is cylinder 1, which is the cylinder we've got the probe on. This is cylinder 3, this is cylinder 4, this is cylinder 2. We can tell a lot about how an engine is operating, especially if it's operating in a failure mode, by just using this Firstlook. You saw how easy it was to put in the exhaust. So all we had to do is put that in exhaust, and we get an idea of exhaust valve opening events and what's going on with the exhaust valve. So we can see if a valve is sticking open, or if a valve is stuck or burned, maybe not sealing. We can do the same thing on the intake by hooking to a vacuum line. We can also do the same thing by taking our dipstick tube. Right down here, we can pull our dipstick tube. We can put a piece of rubber hose on that. We can hook that to our Firstlook sensor as well. And we can get an idea of blow-by events from sealing of rings and things like that. So this is a really useful tool. It's really easy to set up. You can do all 3 tests in probably about 5 or 6 minutes once you're set up with the scope readings that you need and the settings that you need. So again, we're at 20 milliseconds of division right now and 500 millivolts for the Firstlook sensor. So we're looking at 20 milliseconds per division on the scope and event to event. So we get a full cycle on that 4-cylinder engine, and we're getting our 4 cylinders coming back through the exhaust after the power stroke. So I hope you enjoyed learning a little bit about the PicoScope today. It's an extremely versatile tool. It's one that you can use in quite a few applications, and it's something that will make your diagnostic life quite a bit simpler. It is a little intimidating to set up just because of all the settings and the tools that you're able to use and all the attachments that you're able to use. Really, it's something that's kind of unbeatable with regards to how much information you can gather on a vehicle quickly and easily. Again, simple things like ignition waveforms. That is one of our only glimpses as technicians as to what's going on in the cylinder real time. So when there's a failure on a vehicle, perhaps maybe a lean misfire or something that we're trying to diagnose, we're trying to get a hold of, it can really be invaluable in those cases. So you're not going to use it for every vehicle. But I do encourage the use on as many vehicles as you can so that you get used to it, so that you know what it's capable of when you do get a vehicle that might be a little bit more of a problem later. So, again, if you have any questions, feel free to email me, and I wish you luck.